So the box that I have made, which has one entrance, okay, or you can say only the port, I will not make that part also. This is a entry port, this is one more entry port from this end, this one exit port, this is one exit port, this has two terminals from electricity output. So this is a simple fuel cell. Okay, this area will be connected through pipeline of hydrogen fuel. This will be connected to the intake of oxygen. Okay, and it will be an output for the H2O or the water. From here we can connect our load to them, fuel cell, and from this whole process the energy can be converted. This is a very simple factor. Now it internal, we have seen it has anode, it has cathode, in between it has electrolyte. Okay, talking about anode, at anode, okay, the chemical reaction that happens, that is hydrogen is coming. Okay, on the hydrogen you can see what is the input, only hydrogen. The hydrogen is break down into H plus ions plus electrons. Okay, to balance this reaction we will have 2 H plus, okay, and 2 electrons from this. Okay, this is the anodic reaction. And if we talk about at cathode, we have basically coming at the cathode, what all the parts are coming, that is we are coming with 2 H plus ions from here, okay, through the electrolyte. We will have 2 electrons coming from the external circuit. Also we will have oxygen. Okay, so after all this reaction we will be forming a H2O. Okay, and to balance this we will have 2 H2O. Okay, and overall reaction, if we talk about overall reaction, it will be hydrogen plus oxygen. Okay, they are forming 2H2O, and here it will be 2H. So these are the chemical reactions that are happening. Also, now let me tell you one more thing here only. So now you will be imagining what amount of hydrogen fuel we should send. Okay, what amount of oxygen we should send. Okay, here only we can send hydrogen only. Here oxygen can only come. Okay, we do not have any control. Suppose this fuel cell is generating, just for an example I am saying, 2 volt of energy, 2 volt of electricity, just for an example. Okay, suppose we need to run a 48 volt motor. Okay, so we will be needing, you can say 24 more fuel cells, okay, of this 2 volt in series. Okay, we will connect this plus minus of all 24 types of fuel cell in series to generate a 48 volt. Okay, like in case of battery, in battery also we have a lithium ion cell which has a 3.6 volt of energy. Okay, we connect many of the cells in series to basically achieve a 48 volt or basically 60 volt, any voltage level that we need. This is the operation. This is also done with the fuel cells also. Okay, so now suppose we need to power a generator or a generator set or a whole building. So if we keep on using the same fuel cell, so it will be very big structure. Okay, so for that, how we can have different types of fuel cell. In battery you might have we have lithium cells. Okay, we have lead acid cells, or we can have in lithium also we have LFP, different configuration, NMC. We have different types of battery also. But how we can have different types of fuel cell, because hydrogen will remain always hydrogen. Fuel we cannot change. Okay, we cannot take the gas or the basic, this is oxygen, we cannot change. So how we can get a bigger fuel cell or different types of fuel cell? Okay, this implies only that we always have only one type of fuel cell where hydrogen will come, oxygen will come, water will go. Each time it will generate only this power. And if we need to have more power from fuel cell, how we can do? So for that part, so how types of fuel cell are made or classifications of fuel cell, basically they are on the basis of electrolyte chosen. The type of electrolyte we choose, it basically faster the reaction and it will generate more electrons from the same, basically the fuel supply will be different. Okay, the power is similar, but the, you can say, power output of this fuel cell can be changed if we choose different types of electrolytes for the fuel cells. So we can have different voltages, different output from the same fuel cell, same construction fuel cell. Okay, so we will also see the different types of fuel cell that are available, but they are classified on the basis of electrolyte that we have chosen. Okay, we will see this kind of types of fuel cell also in our further slides. See, we have seen that this is a fuel cell where hydrogen is coming, okay, oxygen is coming, and H2O is going out, and here electricity is generated. Okay, this is the part of fuel cell. Now the exit part that is there, the H2O. What we can do, again this hydrogen H2O, it can go through a process of electrolysis. Okay, where we put the electrical energy to break down the bonds. Okay, and from where we will get the electrical energy, we can choose this same electrical energy, we can make connections from here. Okay, this is plus, this is minus. We can again break their bonds of hydrogen and oxygen. Okay, and we can separate the hydrogen again, we can separate the oxygen again. Then again this hydrogen can be connected here in the fuel cell. This oxygen can be again sent to the fuel cell. Again the electricity can be generated, H2O will be generated, and this can be a reversible process. Okay, so this is that I was explaining in our last class also, that fuel cell and electrolysis part are reversible processes. This is just an additional part that I have added. If you want to have a regeneration of this H2O, that also can be done. But if we keep on doing this, if suppose if in isolated system also, if we keep on doing this from hydrogen and oxygen reaction to H2O, then again H2O to hydrogen and oxygen, again from H2O to water, it will not be an endless process. It will stop sometime because there are slight losses in the operations during the process. Okay, in the previous slide I have also mentioned that fuel cells have efficiency of 70 to 90%. So the 10% or 5% that losses are there. So they will keep on reducing our fuels also, and at the end it will stop somewhere. Because there is nothing system that is generated. It can be basically the heat is also generating. Okay, from this chemical reaction we are not only maintaining the electrical energy, some energy is also lost in the form of heat also. A fuel cell will always take its own time because of its limitation. What will be done faster here? If we supply more hydrogen also, still it needs time to break down and go through electrolyte here. Electrons will also take its own time to travel through this circuit. Oxygen supply you can increase, but it is of no use up to when the fuel reaction is not there. Each reaction will have its own time. To do that, what we do basically, that is the actual thing that we want to do in our next classes. But for a brief part, for increasing that power, what we can do, the hydrogen, this fuel cell will keep on generating electricity. We will store that power, excess power, when the vehicle is not running fast, when it is idling. So it will charge a battery pack. Okay, and whenever the high power demand is there from the vehicle, so hydrogen fuel cell also can supply the power, and this charged battery can also supply the power to balance these kind of fluctuations. Okay, that the driver is demanding. Suppose this is the power graph that the driver wants. Okay, hydrogen fuel cell or this part will only have some limitation in a straight line, that it will only generate this thing. So whenever something is up there, so battery will assist. Okay, whenever they lower, so battery will be charged. Whenever up, battery will give power. Okay, for balancing this kind of situations, the one extra storage unit is kept with the fuel cell. That's why we cannot put the motor. Ideally, we can put, okay, but we will not get the exact thing that this part. It will have a constant thing that the motor will run. These kind of part where motor is directly connected through the fuel cells. Okay, it can be done in an application where uniform motion is needed. Like suppose there is some industry which needs to rotate one shaft at a same speed. There we can directly connect this fuel cell. Proper supply is there. Okay, there it can keeps on running at a same speed. Okay, electricity is also generated. It is consuming. The rate should be same. Okay, if there is some change in the rate of generation of electricity and consumption, so for that we need to have something in between to balance that. Okay, that is our application of automobiles, you can say. Type of fuel cell is linked with the electrolyte. So if you talk about the electric vehicles that we use a PEMFC, that is proton exchange membrane. Okay, this is called proton exchange. We will see all these also in our further slides in this module only. Proton exchange membrane, it basically generates it has some temperature ranges also. It goes up to 60 to 90 degrees Celsius, which can be easily we can implement in our electric vehicles. Okay, this power. And if we goes for the higher applications, basically fuel cell this heat temperature goes up to 1000 degrees Celsius also during their power generation. We will see these all kind of thing, that is SOFC, AFC. AFC is basically alkaline fuel cell, solid oxide fuel cell, okay, molten carbonate fuel cell. We have different types of fuel cell. We will see all of them one by one.